In the last example, we looked at a specific example. We had f of x equal 2 to the x, and we saw that the inverse function was the log base 2 of x. And if this function could be written as y equals e to the x, this can be written by switching the roles of x and y. I'm sorry, not e, 2. My base was 2. Okay, this generalizes. So if g of x is b to the x, where b is bigger than 0 and b isn't 1. So if I have any exponential function, I can say that means that y equals b to the x. That would be the original function. X equals b to the y would be what the inverse function means. And then we just rearrange it. We say y equals the log base b of x. That says y is the log, so y is the exponent. You can see it's in the exponent position. When b is the base, b is in the base position, to get x. X is the result. Okay. And, of course, if I want to use inverse function notation, that would mean g inverse of x is the log base b of x. Okay. So, any positive number other than 1 is a legitimate base for a log function, because those are the inverses of exponential functions, and those were the legitimate bases for our exponential functions. All right, excellent. So let's just practice evaluating a few more of these. Let's say I had the log base 5 of 125. And let's try the log base 25 of 5. Okay. Now, depending on how comfortable you are with that, if you want to pause the video and give those a shot on your own, that's fine. We haven't done a lot of examples, so if you want to work through these two together, that's fine. I'll be giving you more to practice on in a bit. But if you want to pause the video now, go ahead. Otherwise, stay tuned. Okay, for both of these, I find it helpful when I'm evaluating a log function to turn this into an equation by just giving this a name. If I give it a name, now I've got an equation that I can rearrange. And obviously these two x's are not the same. So for this problem, I would just rewrite things. So I'm going to have a base, an exponent, and a result. So let's see, this says the exponent I need when 5 is the base to get 125. Is x. The log is x, the exponent is x. So 5 to what power is equal to 125? Let's see, 5 squared would be 25, 5 cubed would give me 125. Okay. So here x, which was our log base 5 of 125, is just 3. All right, if I look at this one, again, I've got a base, an exponent, and a result. Okay. This says the exponent I need when 25 is my base. To get 5 is the result. Now that feels a little strange because we're used to having the bigger number be the result and the smaller number be the base. This is switched. We'll survive. The log is x, so the exponent is x. Now, if this were a positive integer, I'd be getting numbers bigger than 25. Doesn't look like I want a negative exponent because I'm not getting a fraction, I'm not getting a reciprocal. What's the relationship between 25 and 5? That's the square root. The square root is the 1/2 power. So x, which is the log base 25 of 5, is just 1/2. So it's really all about looking at the relationship between these numbers and trying to express that in terms of some exponential expression. Now, there are two bases that are super important because those two bases are used the most frequently. They'll show up in the most applications, and they're the two bases that come with a key on the calculator. There is no log 2 key on most calculators. There is no log 5 key on most calculators. They're starting to get more advanced, so with some calculators you can hit log and then enter what you want the base to be. But most calculators, at least up to a year or so ago, I'm not sure if it's changed that much since then, just have 2 log keys. So there's the common log, and that's base 10. Okay. And if I write log of x, and I don't put a subscript here for the base, that means the log base 10 of x. It's the one base that you don't have to write. If you just see log with no base written, it's the common log, and that means that it's base 10. Okay. Now, this is how it's going to be written in your book. That's how it's going to be written in almost anything that's published. If you find it helpful to write in that the base is 10, this is totally fine. It's not standard. Most people are lazy enough that if they don't have to write a 10, they won't. But as you're learning, if you find it helpful to have that sitting there, totally fine to write that in. But it is your job to recognize that this symbol means the same thing as this. So if it's not written, you need to know the base is 10, whether you choose to explicitly write that or not. Okay. And then there's the natural log. Okay. This is named after the fact that it shows up in the natural world a lot, and that's going to have as its base e. We call e the natural base. Okay? So the natural log is written as ln of x. Okay. Now, ln, looks like we got it backwards. Well, in Latin it would have been something like logarithmus naturalis or something like that. Okay, so this does stand for natural log. Okay, that is an L, not an I. It's not the word in, it's ln. Okay, standing for natural log, but in Latin they put the log word first and then the natural word second. Okay, all right, so ln of x means log base e of x. You will almost never see it written this way. This is standard. If, when you see this, you want to rewrite it this way, it's perfectly correct. You're more than welcome to do that, and some of you may find that it's helpful to have that visual of there's an E in the problem then. Okay, so that's totally fine. Okay, but you're responsible for knowing that that's what that means. Okay, and standard calculators will have a key that just says LOG, that's for the common log, and they'll have a key that says LN, that's for the natural log. So let's just practice a little bit with this. Let's evaluate the log of 1,000. Let's evaluate the log of 0.0001. Let's evaluate the natural log of e squared. And let's evaluate the natural log of 1. Let's try these 4 together, and then I'll give you a couple to try on your own. Okay. So with all of these, I find it helpful to just give that a name. Okay. If x appeared somewhere else, I'd call it something else, but giving it the name x. And then I'm just going to rearrange this. I'm going to have a base, an exponent, and a result. Okay. Now, this is log. That means common log. If I want to, I can write in that 10. That's entirely optional. Whether I write it in or not, I need to know if it's just log, that means the base is 10. Okay. So, let's see. The exponent I need when 10 is my base to get 1,000 is x. Nifty thing about powers of 10, there are 1, 2, 3 zeros. That's 10 to the third. Okay. So, this would just be 3. Okay. Here, I'm going to call this x. So, we've got a base, an exponent, and a result. Again, because it's the common log, the base is 10. Okay. The result this time is 0.0001. The log, or the exponent, is still x. Okay. Now here, I can't just count the zeros. That's actually going to give me something wrong. But I can say this is 1 over, let's see, this is the tenths, hundredths, thousands, 10,000ths place. Notice this is in the 1, 2, 3, 4 digits to the right of the decimal. So it's 1 over 1 followed by 4 zeros. So I can count places, but I'm not just counting zeros here. Okay. Well, that's a reciprocal, so that tells me that we're going to have a negative exponent, and it looks like it's the reciprocal of 10 to the 4th. So this would be a negative 4. Okay. For this one, I'm going to give this a name. I'm going to call it x. And again, because this is the natural log, if I want to, I could call this the log base e of e squared equals x. I won't usually rewrite things this way because I know it's never going to be given to me that way. So I'm going to try to get us comfortable with just ln for natural log. But if you find that it works better for you to copy this, takes all of 10 seconds, it's worth it. Okay. All right. So now I want to rearrange that into an exponential expression. So we'll have a base, an exponent, and a result. The exponent I need when e is my base. E squared is in the result position. The thing that follows the log, so in this case the 1,000, here the 1/10,000th, here the e squared, here the 1, we call that the argument of the log. It's just the thing that becomes the result when you rewrite things in exponential form. And the log is x, so the exponent is x. Wow! This problem looked a little intimidating at first, but now it looks pretty simple. E to what number is the same as e squared? I'm thinking x is 2. Okay? So once you rewrite it, it actually becomes kind of nice. So don't be too intimidated by this. Okay. So here, natural log of 1. Again, I'm going to give it a name. I'm just going to call it x. That allows me to rewrite my equation in exponential form. So because it's the natural log, the base is e. The argument, which is the thing I'm going to get, is 1. The exponent, the log is x, so the exponent is x. E to what power is 1? 0. Anything to the 0 power is always going to be 1. Okay. So this is just 1. Excellent. Okay, so I'm going to give you a little bit of practice in evaluating some logs. I'm going to put 3 problems up for you to try. Try them before you watch the next video, and then in the next video, we'll go over these together. Okay, so let's try the log base 4 of, let's try 64. Okay. And then the next 2 are from the homework. This is 29 from the homework. The log of 100 million. And then 37 from the homework is the natural log of an ETH. I like to call that an ETH. It's 1 over E. Okay, so this one I just made up. These 2 are getting you a head start on the homework. Try evaluating those. Again, I recommend give them a name, rewrite your equation. When you give it a name, you say equal something, then rewrite that equation in exponential form, and you should be able to solve these by inspection. You're not using a calculator for these, okay? There are logs where you do need a calculator. These are not those.